Hi folks, we're going to have a look at density, mass and volume today, okay, quite an important topic. You need to have this, I would take down at least 2 examples from this today, at least into your books, more if you can, but this formula here is particularly important, okay. Now, the density of an object is essentially how tightly packed it is, okay. I have gone into more detail about that in the lesson, in the PowerPoint. Okay, but density is essentially how dense something is, okay? So you hear when people have a cake and it's a dense cake, okay, it's really packed in there, okay? That's what it means. So you could have, I think the example I've used is a sponge and, I don't know, it's like a slab of concrete or something. They've got the same volume, but actually the sponge is a lot less dense, okay? It's got lots of holes and things in it, okay? So anyway, density, mass and volume. Now, a lot of people like to write this as a triangle. It saves them rearranging it. I don't mind if you want to do that. It looks like this. So, if you want to use that instead, I'm more than happy for you to do that. That's the one I tend to go with. Density, mass and volume. The way I remember the order is, I think, of the Department of Motor Vehicles in America. You hear about it on the TV, you know, in TV sitcoms. They talk about the DMV, the lines at the DMV, that kind of thing. So, DMV. However it helps you to remember it. Right then, so here's an example. I've got 4 of these for you. A cuboid has dimensions of 9 centimetres, 3 centimetres and 12 centimetres, and its mass is 194.4 grams, okay, and we're going to calculate its density. So first of all, we're looking for density, okay, so density is mass divided by volume, so it equals mass over volume. So we know the mass, it's 194.4. We don't know the volume yet, we're going to have to calculate it. And because this is a cuboid, and these are its 3 side lengths, we can just multiply those 3 together to get the volume. If it helps to draw a sketch, please do. Okay, I would always recommend doing a sketch in this kind of situation. So we've got 12 centimetres, 9 centimetres and 3, and it is just a sketch, you don't need to be measuring this thing out. But to find the volume, we find the area of the end there, okay, and then multiply it by the depth. So we've got 3 times 9, which is 27. The cross section, that's the word I was looking for the cross section, okay, so that's 27 centimetres squared. And then we multiply that by 12 to get 324 centimetres cubed, okay. 324 centimetres cubed. We won't write in the units in the working. So we calculate that, and that should give us our density. So we get 194.4 divided by 324. Which is 0.6. Now then, units, and this is why this comes under kind of the heading of compound measures. Our units are whatever we've put in, okay, so if we've put in grams for our mass, and we've put in, centimetres cubed, okay, for our volume, that's what comes out, okay, so we get grams per centimetre cubed. Okay, now that's the most sensible way to do those. Look at what's gone in, and that's what's going to come out, okay? So density is measured in grams per centimetre cubed. Right then, so there's your first example. These first 2 are actually on the PowerPoint, they just don't have the working with them. So we've got a cuboid here with dimensions of 2 metres, 90 centimetres and 140 centimetres. Its density is 0.8 kilograms per metre cubed, and we're going to calculate its mass. So the first thing I'm going to do, I'm going to put in my little triangle again, so D, V, like that, just a sketch, and it takes a second, and we're looking for mass. So very much like when we were doing trigonometry, we cover up the thing we're looking for, and whatever's left is our calculation, okay? So we're looking for mass, so we write it over there, we cover it up, and it's density multiplied by volume. Okay, now then, this time we've got another kind of a bit of a trick in here we've got to look out for. Our density is given in kilograms per metres cubed, okay, but our measurements, we've got metres and centimetres. We need to convert. Now, we could convert them. It would be easier to convert the 2 metres into centimetres rather than making 2 conversions here. However, because this is in metres, we need to convert these into metres as well, okay. Otherwise, we're going to have to start converting all of this. It's much easier to just convert these ones. So, sketch of our cuboid. We've got 2 metres on one side. 90 centimetres in metres is 0.9, and up the side there 140, which is 1.4. Okay, so we calculate the volume, 1.4 multiplied by 0.9 multiplied by 2, which is for our volume. We get 1.4 multiplied by 0.9 multiplied by 2, which is 2.52 metres cubed. Okay, we're in metres this time. Right then, so now we've got our volume and we've got our density. The calculation is going to be 0.8 for the density multiplied by 252. If I have put a decimal in there, yeah, that's okay. 2.52. Okay, to get the mass, so 2.52 multiplied by 0.8, which gives us 2.016. Okay, for the mass. And again, units, okay, our mass is like a measurement of weight, so the weight that we put in there, the mass was measured in so the density was in kilograms per metres cubed, so the mass that comes out is kilograms, because that's what we've used to go into it. Right then, there's the first two. Now, oh, this one's upside down for some reason. There we go. A couple more slightly different ones, just so you can kind of, you know, get a bit of a feel for them. A bottle is filled with 2 kilograms of olive oil, which has a density of 0.925 grams per centimetre cubed. What is the volume of the olive oil to the nearest centimetre cubed? Right then, so once again, as soon as we see things like the words density and volume, we know we're going to be pretty much guaranteed to need to use this DMV triangle. Okay, we're going to need to use that, multiply there. So we are calculating the volume this time. So we're looking for volume. I'm going to cover up volume. I need to do mass divided by density. Mass over density. Right then, and what have we got here? So we're given a mass of 2 kilograms and we're given a density. And now our density is actually in grams. So I'm going to convert my kilograms into grams. Okay. So instead of 2 kilograms, I'm going to write in 2,000. Because I'm going to convert it to grams, because they've got to be in the same units here, and that's going to be divided by the density of 0.925. Okay, so we've got 2,000 divided by 0.925, which is 2162, and this is to the nearest centimetre cubed, so it is 0.16, so actually it's just going to be 2.162 once we've rounded that. And our units, don't forget, it's a volume, so our units are going to be cubed, but it's going to be centimetres cubed, because that's what we've put in there, centimetres cubed. Okay then, right, so one more example and then I'm going to let you have a go at some by yourselves. So we've got a cube with side length 7 metres and it's got a density of 10,800,000 kilograms per metre cubed. And we want to know what its mass is. So we've got our DMB. There we go. And we're looking for mass. So mass equals density multiplied by volume. So we've got a density already. We've been given that is 10. We're going to have a lot of numbers on this one, isn't it? And we're multiplying that by the volume. Now our cube. Now, do you know, it's a bit of a hint here for maths, but if you're ever told cube in a question, it's important, okay? It's particularly important, because what we know about a cube is they've all got the same side length, okay? It's pretty much always relevant. If they go to the effort of saying the word cube, it's going to be relevant that all the sides are the same length. So to calculate the volume of a cube, it's going to be 7 cubed, 7 times 7 times 7, which I think is 343, yep. 343. So I'm going to multiply that by 10,800,000. So how many zeros have I put in now? 1, 2, 3. Is that all of them? Yep, that's right. And we get, right, bear with me while I copy this one down. We get a 3,704,400,000. Okay. What we get when we've got that one there, we have got a unit, it's a mass. We've put in kilograms, so it comes out as kilograms. So it might be worth just putting a note, okay, of the type of units you'd expect for each of these. So mass, we're looking at traditional kind of weight measurements, so kilograms, grams, pounds potentially if we're working something imperial, etc. Pounds like that pound, not the money pound. Mass, density, we end up with things like kilograms per metre cubed or grams per centimetre cubed, etc. And volume, you should be familiar with those, centimetre cubed, metre cubed, etc. Okay, it might be worth just having a list there, just to keep them kind of fresh in your mind. It's easy to get a bit confused when you're kind of bogged down with all of this. Right, head back to the PowerPoint now and just carry on working through that. There's some practice questions on there for you.